Hello everyone, I'm just glad to have you here. So in this video, in this one short video, we are going to complete our NumPy series. We are going to start our NumPy series, which we will be completing within, I would say 2 to 3 hours, where we will be learning a complete NumPy that is required at industrial level to become an data analyst or a data scientist, right? So as you can see, I have opened a PPT where you can see my heading NumPy numerical computing in Python, right? So what is NumPy? Let's get straight to the topic without any further ado. Okay, so what is NumPy? So basically NumPy is a Python library, and it is a kind of short form of numerical Python, right? And from the name you can recognize, or you can just process your mind that yes, it must be helpful for numerical computation. Let's read some PPT and theory. Don't worry, we will be learning practical in Jupyter Notebook with Python, doing some practical approaches with real world examples, right? Okay, great. So what is NumPy? So NumPy, pandas, then SciPy, which stands for scientific Python, and matplotlib, that is useful for visualization, right? So these libraries provide functionalities for data analysis in Python. So here I have written some features of NumPy, like it is typed multi-dimensional arrays. Okay, you can think of this as a matrices, right? You must have studied vectors, matrices, tensors in your school days. So matrices, then it provides fast numerical computations, right? Like matrix mathematics. Okay, don't worry, we will be discussing about this with practical approach very soon enough. Okay, and it has high level math functions, right? For example, we want to get a mean, median, mode, or standard deviation, or maybe a product or dot product of a large amount of data of a matrix of a tensor, then we can easily get it with speed, right, as compared to lists from Python. Okay, right. Now the question is, why do we need NumPy? What was wrong with the Python list, and why do we not need list, and why we need NumPy? Okay, so let's see it for ourselves. Okay, so basically Python does numerical computation, to be honest, very slowly, right? And you must have heard about this, that Python is a slow language. Okay, but since NumPy is built for data analysis, so we will be working with large amount of data, with huge amount of data. So slow computation may not be efficient with core Python or core list like data types, right? But so that's why we need NumPy, that is helpful. Like as you can see here, if we want to multiply 100 by 100 matrix, then Python triple loop takes greater than 10 minutes, which is quite high, and we don't have that much time to just for this small computation, right? So this is, yes, this is not a big computation, this is just a small computation. We will be learning about this throughout the course. Okay, while NumPy takes only 0.03 seconds. As you can see, why we should be using NumPy. Okay, now let's take some overview of NumPy, that what we are going to cover in this series. Okay, so first of all, we will be learning arrays. Arrays is a data structure that you can think of this arrays as a matrices, as I have mentioned before, or maybe crayons. Okay, colorful, basically crayons. I hope you have heard about this. Okay, so let me go to the browser directly, and I would press escape. Oh, don't worry, let me open another tab, and crayons. Okay, so what are crayons? Okay, so as you can see how these pencils or color pencils are organized, right? They are in organized way, basically, right? So we can have our data in organized way. First of all, you will get a raw data, like, right? So what is your duty as a data analyst? Your duty is to organize data in a meaningful way, in a insightful way. Okay, so we can, arrays can help us becoming a data analyst easily. Okay, all right. Then shaping and transposition, then we will be learning about mathematical operations. We will be learning about how we can index or slice our data, and we will be also learning about broadcasting. Okay, then we will learn about scalars, vectors, matrices, how images and arrays work, then how tensors work. Okay, so Yes, so we will be learning a lot about this, but before getting into the practical, let's learn some theoretical concept, and let me revise you the concepts of your high school time, right? Like what are scalars and vectors and matrices like. So scalars are basically they have no dimension. If I have this, let me go to the VS Code, and if I'm writing here, let's say a is equal to 10. So 10 is what? 10 is nothing but a scalar only, right? So this is scalar. Okay, scalar. Then what is vector? As you can see here that it is one dimensional, right? So this is basically vector. Then this is matrices, where there are two dimensions, row and columns. Yes. Then we have images and tensors means three or greater than, when we are working with three or greater than dimensions, then we basically say it tensors. Okay, so let me google it for you. The difference, okay, the difference between scalar, vector, matrix and tensor. I'm just hoping that I will get a good image of this. Yes, you can see that this is scalar, this is a vector which is one dimensional, this is matrix, that is two dimensional, row and column both. But when we have greater than two dimensionals, right, greater than, yes, greater than two dimensional, then we basically say it as a tensor. Okay, so these are very useful terms that we will be using throughout the course. Okay, so make sure to remember them. All right, so I will be discussing about this later on, because it will blow your mind, something like this convolutional nets. Okay, so yeah. Okay, so yes, this was all about theoretical concept and a bit of introduction to NumPy. Okay, but I know everything is empty without everything is empty without practical approach. Okay, but don't worry, let's get into the practical without any further ado. So before getting started with NumPy, let's get introduction to the Jupyter notebook, where we will be learning about NumPy. Okay, so first of all, make sure to create your virtual environment. Okay, it's a good habit and good practice. So if you haven't already installed your virtual environment, then you can simply write pip install virtual env. Okay, but since I have already installed, I'm simply gonna create it once again, something like this: python dash m venv. Then I will name it here, let's say my env. Okay, so this is how you can create your virtual environment. Okay, I hope you have heard about virtual environment and you have some basic idea about, I'm expecting that you have some basic idea about core python as well. Okay, so this creates basically so many packages and libraries. Okay, so it may take a little time to get, yes. Okay, so hey, it got installed. Okay, and to activate this, you can, if you are on Windows, then you can simply write my env, then tab, then script. Okay, and then activate. Okay, so this will basically activate my virtual environment. Or if you are on a different OS like Mac OS or Linux, then you can simply Google your command. Let me get it for you. How to activate? You can simply write how to activate virtual environment in Linux or Mac. Okay, so your goal should be nothing but to get to this activate script. Okay, so I just came into my env, then into script, and then into activate. Okay, so in the Stack Overflow, in the different websites, you will definitely get the Python documentation as well. You will get the idea on how you can activate your virtual environment in different OS. Okay, so I have now installed my virtual environment and activated my virtual environment. I will simply install nothing but Jupyter Notebook, okay, and NumPy. Okay, Jupyter Notebook and NumPy. So you have idea about NumPy. We just discussed it, not discussed it, but discussed it. Okay, and I'm just installing Jupyter Notebook. So Jupyter Notebook is nothing but a kind of IDE that I personally find convenient. Sorry, yes, that I personally find convenient to code NumPy, Pandas, and Matplotlib. Okay, and soon you will find it convenient as well, because sometimes I find that VS Code or PyCharm is slower to execute such code and to handle such amount of data. But as compared to NumPy, sorry, as compared to Jupyter Notebook, it is quite faster, right? So yes, it has just got downloaded, and I think it's getting installed now. And as you can see, there are so many packages are downloaded here. Okay, but not to worry about it. Okay, our virtual environment, our yes, my env will handle it carefully. Okay, it is generally a good practice to avoid version conflicts. For example, if you are working on multiple versions of Python or Jupyter Notebook or NumPy or Pandas, then virtual environment are quite useful. Okay, all right. So now it's soon enough. It should get downloaded or installed. All right. Meanwhile, this is getting installed. I shall just show you one more IDE, that is Google Colab. Okay. You can also code in Google Colab. Okay. That is provided by, of course, Google. Okay. And it is a kind of Jupyter notebook, but on the server. So you can just save your code on the server, or you can just, use some amazing features like this. Okay. Not worry. We will be coding about like this amazing charts as well. Okay. And yes, this is Google Colab, where if you are, it is quite useful when you are working in a big project with multiple developers or analysts or scientists, data scientists, I mean. Okay, and this becomes quite useful. Okay, and I hope now this should get installed. Okay, don't worry. Let me get you through Jupyter Notebook website. Okay, so some may say this as a, some may pronounce this as a Jupyter, or some may pronounce this as Jupyter, but whatever it is, an IDE end of the day that we are going to use to code our NumPy, Pandas, and Matplotlib. Okay. Oh, all right. Okay, so now the wait is over, and this has successfully got installed. Okay, now to activate this to run our IDE, I will simply write Jupyter Notebook. Okay, and as you can see, the process has started. No, you cannot see. Yes, now as you can see, the process had started, and this just opened my browser. Okay, and this will be running completely in your local system. Okay, so you don't even need internet access, but yes, definitely you need internet access to download some packages and all. Okay. All right, so let's first get intro to this IDE. So by clicking on this new, I will simply create a new .ipynb file. Okay, yes, remember this extension. It is not .py file like Python, but it is .ipython notebook. Okay? In short form is .ipynb. Okay, I will just rename it from here. Let's name it as of now intro to NumPy. Yeah, intro to NumPy. Okay, and yes, this is my cell. You can just add cell by clicking on this add cell button. You can also add cells like this. Okay, like above and below, you can add some cells by clicking on this delete button. You can delete the cells. Okay, and now I should get to the topic rather than this sheet. Okay. All right, so since now we have successfully activated our Jupyter Notebook, our virtual environment, let's start with a NumPy. Okay, and yes, this is just a menu bar of this, and it is a kind of similar to the VS Code or PyCharm menu bar. You will just find this new option, that is kernel. Okay, what is kernel? This is kernel. Let's say if I'm writing this import NumPy as np. Okay, and this cell will get executed. Okay, now if I want to restart this kernel means this is all that you are saying. Okay, if I restart kernel and run all cells, so this will basically restart this kernel, restart this book, and it will run all the cells line by line. Okay, so eventually you will get addicted to this and you will get used to this. Okay, so no need to worry about this. And yes, I'm not forcing you to use this, and I'm not of course sponsored by Jupyter Notebook, but yes, you should be using this. This will help you a lot, especially when you are working data visualization. Okay, and I really find this convenient to use as compared to VS Code. Okay, but at the end of the day, the choice is yours. Okay, and you can code in whichever ID you feel comfortable. Okay, right. So we have successfully imported our NumPy as NP. Okay, we did write here as NP. That is basically alias, right? And why did we do that? It's because we don't want to write all the time numpy.array. We can simply write np.array from now, since we have imported numpy as np. Okay, all right. So now let me introduce you to the scalar vector tensor and matrices. Okay, or yeah, some may pronounce it as matrices, or but I pronounce it as matrices. Okay, all right. So what are scalars? Scalars, vectors, matrices, and tensors. Okay, now let's see this with practical and hands-on approach, right? So if I write here that uh, scalar is equal to, let's say, 10, so this is nothing but a scalar only. Okay, but if I want to create a vector, then I will use numpy for that. Okay, so if I write here vector is equal to nothing but np dot array. Yes, np dot array is a method to write or to create an array. Okay, so np dot array, and if I go on here like 1 2 3 4 5, so this is a vector. Okay, basically vectors are one dimensional. Okay, and to check the dimensional of a variable of a vector, you can simply write here vector. Oh, I misspelled it. Okay, don't worry. Vector dot ndim. Okay, ndim, that means nth dimension. Okay, nth dimension. Okay, so this will return us nothing but the dimension of the vector. So as you can see here, it is 1. Okay, how to create a matrix? Let's have a look at this. For example, if I'm writing here matrix is equal to np dot array, and then I will do nothing but I will write a two-dimensional array like this: 1 2 3, again a comma, and 3 4 5. Okay, and if I print here a matrix, then this is printing something like this. And if I want to check dimension of this matrix, I will simply write matrix dot name, and this is returning 2. That means this matrix has two dimensions. Okay, now if I want to create a tensor, let me create a tensor. Tensor is equal to np dot array, and now I'm going to create three-dimensional array. That is quite hard, but not impossible, of course. Okay, so yes, I have did this first bracket, and I will do this second bracket, and again I will do this third bracket. Okay, so number of dimensions is equal to number of brackets. Okay, here we are writing for one dimensional, so I did only one bracket, and since we are working with two dimensional here, I did two brackets, and since now we are working with three dimensions, so I did three bracket. Okay, and yes, if you want to master this, you need to have some practices. Okay, don't worry, I will give you those practices, right? 1 comma 2 comma 3, again I will write 4 comma 5 comma 6. Okay, and let me just copy paste this here. Okay, and now if I print the tensor, as you can see that this has successfully created three-dimensional array. How do I know this is three dimension? Because of course I have created this, and if you want a proof, you can simply write tensor dot name. So this is giving us 3. Okay, that means that this tensor has three dimensions. So, okay, so these are scalars, vectors, matrices, or tensors. So I hope now your memories of school days is revised once again, and you now very well know what are these concepts. Okay, I'm teaching you this, and we are learning this because this will be quite useful when working with large amount of data very soon enough. Okay, all right. So I hope now this is very clear to you. Okay, all right. Now if you want to get the size and maybe the shape of the array, how we can get the size or shape of the array? By simply writing, let's say I have this matrix, and yes, this is one of the beauties of Jupyter notebook, that we don't need to write print statement all the time. I can simply write the variable name. Of course I can write print statement, nothing wrong with it. Okay, print matrix. Okay, so this will return me something like this, and even if I don't write print statement, this will return me the output. Okay, so yes, all right, let's get back to the topic. Matrix dot size. Okay, if I write matrix dot size, then this is returning us 6. If I write tensor dot size, tensor, I again misspelled it, tensor dot size, then this will return us 12. Now what is this 6 and 12? Now let's look at matrix. Okay, so matrix has basically 6 element in it, right? And tensor has 12 elements in it, like this 6 plus this 6 is equal to 12. Okay, so size is nothing but number of elements. Okay, size is nothing but number of elements present in an array. Okay, now if you want to get the shape of the array or matrix, you can simply write matrix dot shape. Okay, and you will get that 2 comma 3. Okay, now what is this 2 comma 3? If I write here tensor dot shape, then this will return me 2 comma 2 comma 3. What is this 2 comma 2 comma 3? So matrix dot shape is returning us 2 comma 3. That means that it has 2 rows and 3 columns. Let's print a matrix here. Okay, it is printed already here. Okay, so it has basically 2 rows and 3 columns. Okay, so this is a row, this is a row, this is a column. 1 3 is first column, 2 4 is second column, and 3 5 is third column. That's why it is giving us 2 comma 3. And why 2 comma 2 comma 3? Because it has 2 parts. Okay, each part contains 2 rows and 3 columns. Okay, so I hope you now get the topic of how we can get the size, shape and dimensions of the array. Okay, so this is how we work with arrays. Now if you want to generate arrays without writing much code, okay, like for example, if you want to, if you wanted this array, we just brought this much code, right? But we can get some arrays without writing so many code. For example, if I write here like let's say array 2D. Okay, array 2D, basically I'm generating two-dimensional array. So array 2D is equal to, if I write np dot zeros, yes, we have a zeros method, and if you want to get some idea about these methods, you can simply click on this method and press shift tab together. Okay, shift tab. So you will get the details of this method. Like we are working with zeros, so it takes argument as shape. First of all, we have to pass the shape, then we can also pass data type, then we can also pass order. Okay, and like is equal to none is by default value. Okay, so yes, so and here you can see here are some set of examples like np dot zeros, and since it has written only 5, so it is generating 5 zeros. Okay, so let us try this as well. Okay, so if I write here np dot zeros and into bracket 5. Okay, so let me first regenerate some of the cells, and now if I print array 2d, okay, array 2d, then this will generate 5 zeros. Okay, now if I pass here in a tuple or maybe tuple, let's say 10 comma, that will be too large, let's skip it, 4 comma 6, and if I run this, then you can see that it has generated a 2D array containing 4 rows and 6 columns. Okay, so 4 rows, this is first row, this is second row, this is third, and this is fourth row, and this is first column, second column, third column, fourth column, fifth column, and sixth column. Okay, so we can basically generate something like this. Okay, since we have this zeros method, we of course have one more method, that is ones. So if I write here new or maybe array ones, okay, array ones is equal to np dot, we have ones method. Okay, and by pressing shift tab you can get the details of this method as well. Okay, and if I pass here in a tuple, let's say 2 comma 3, so this will generate an array containing one value in something like this. Okay, so if I write here, so as you can see, it contains one value and it is generating 2 rows and 3 columns. Okay, we can also specify the data types by simply passing another arguments. Okay, like data types is equal to let's say if I want to keep it float of 32 bits. Okay, so you can see here it has generated ones, number ones means an array containing one value with data type float 32. We can write integer 32, integer 64. Okay, all right. Then if you want a specific number, if you want to generate an array something like this, but with a specific number, not 0, not 1, but let's say you want to get an array with 10, then simply you can write array 10 is equal to np dot full method. Yes, you can use full method, and if I write here 2 comma 3, and if I give here a value that is nothing but 10, and if I print here array 10, okay, then this will return us a two-dimensional array containing 10 value, and the shape is nothing but that we have passed here 2 comma 3. Okay, so this is how you can generate an array without writing much code. Okay, Now you must be remembering earlier that in this PPT I said that where is it? Where is it? Yes, that NumPy has faster numerical computations. Okay. Now, if you are doubting my this statement, then I'm going to show you a little bit of proof that why NumPy is faster than core Python list data structure. Okay, so stay tuned. Let me go through here. Okay. So let's compare here first of all in a markdown cell. You can, if you want to write a simple data with not code but a kind of detail or maybe a comment, then you can simply write markdown cell. Okay. So if I'm writing here the difference between a list, and a NumPy array. Okay. So first difference I find is nothing but it is that list is, or I would write array is faster than list. Okay, then list arrays can have multiple dimensions. Okay, now let's see how arrays are faster or NumPy is faster than core Python. Okay, so first of all, if I want to generate, like if I want to compute the time, then I will use import time library. Okay, I will use time library just because I want to get the difference between starting point and ending point. Okay, so I just imported time and I will write here that start time. Okay, start is equal to simply we will write, we want current time, so I will write time dot time. Okay, and you may be aware of a list comprehension topic. Okay, list comprehension, and let's try it by checking. Let's say if I want to generate a number or a list containing the range between 1 and let's say 1 million. 1 2 3 4 5 6. Okay, I want to generate a list containing a range between 1 and 1 million. Then let's see how much time is taken by list and how much time is taken by NumPy array. Okay, so I will do it simply by list comprehension, that list list array or list range is equal to I for I in range, and I want a range between 1 to 1 billion. That is 1 2 3 4 5 6, and this is my starting time, and I also be needing I also need ending time. Okay, so end is equal to of course time dot time. Okay, and if I really want to get the difference between like if I really want to get the time, that how much time did this take, right? So I will simply write the difference, print the difference is, or maybe the time, yes, the time taken by list to generate 1 million data is, and I will simply write comma, and of course I will write and minus start. Okay, so this will give me a proper number. So if I run this, so you can see that list takes 0.14 second to generate 1 million number. Okay, and now let's see that how much time is taken by NumPy arrays. Okay, so I will do the same process, time dot time, and I will write array range. Array range is equal to, now NumPy has a method called arrange. Okay, so I will simply write arrange. Okay, to get the number of data between some particular ranges. Okay, so np dot arrange, and I will simply write here start point, and I will write here end point. That is 1 2 3 4 5 6. That means 1 million. Okay. So yes, it is generating a range between a range, that means array range. Okay, and n is equal to time dot time, and let's print this once again. Okay, and now let's regenerate this and regenerate this. Okay, so as you can see that list has taken 0.19, that is approximately 0.2 seconds. Okay, this is still quite faster. Okay, but yes, quite slower and far more slower than array. Okay, since array has taken only 0.03 seconds to generate this number of elements, while list has taken 0.2 second to generate this number of element. Okay, so that's why I have been saying continuously that why we should be using NumPy instead of instead of lists. Okay, so this is why I have written here this, that arrays is faster than list. So this makes us feel that yes, this is convenient to say that arrays are good when working with large amount of data. Okay, and also that I hope now I was able to convince you that why we should be using arrays instead of NumPy when you are working with large amount of data. And in the next segment of the video we will be saying how we can perform how to perform computation, how to perform, or I would say mathematical operations in NumPy. Okay. Yes. Before getting into the next segment, let me show you one more difference. Okay. Let's I have this list. A is equal to 1, 2, 3. B is equal to 4, 5, 6. Okay. And if I write here A plus B. Okay. Sorry, that was my mistake. A plus B. Okay. And as you can see that this has simply merged my two lists. Okay, and now let's try to perform the same operation in the NumPy. Let's say x is equal to np dot array and 1 comma 2 comma 3, and here I will write 4 comma 5 comma 6, and this will be y. Okay, and now if I write here x plus y, then you can see that it didn't merge two arrays, but it did what? It simply computed the summation of each element, like 1 plus 4 is equal to 5, 2 plus 5 is equal to 7, 6, 3 plus 6 is equal to 9. Okay, so this is one more reason that why we are using NumPy for mathematical computation. Okay, right. So this was all about the difference between list and array. What are arrays? How we can generate arrays? How we can create arrays? How we can get the size, shape, and dimensions of the arrays? And as well as we have learned about what are scalar, vector, matrix, and tensors in this segment. Okay. So in the next segment, we will be learning about vectorized operation performed in an array. So in this lecture, we are going to learn, or in this segment, I would say, not lecture, in this segment, we are going to learn how we can perform vectorized operations in NumPy arrays. Okay, so I just gave you a little glimpse at the end of the last segment that what are vectorized operations, but let's cover it a little bit in detailed. Okay, let's say I have this x and I have this y variable, x array and y array. Okay, so vectorized operations are nothing but they are they are element by element operations. Okay, for example, if I'm writing here x plus y, then this is just computing, or this is just summing each element from the x and y array, like 1 plus 4 is equal to 5, 2 plus 5 is equal to 7, and if I write here x into y, so that will give us nothing but 4, 10, 18, that element wise operations. Okay, vectorized operations simply mean that element wise computation. Okay, computation. Okay, so these are vectorized operation. If I write here x by y, then this will return something like this. If I write here x minus y, then this will return something like this. Okay, now let's get that how to generate random arrays. Okay, random arrays. Okay, so to generate random arrays we use random method. Okay, but not solo random method, because it is a library that we use in core python. Okay, but in this numpy array we will simply use let me write a variable random arr is equal to np dot random dot rand method. We will use np dot random dot rand method. Okay, and here I will pass shape. Okay, so if I write here that 10 comma 4. Okay, so this will return us something like this. Okay, and I need to print it, of course. Okay, so as you can see, this has generated 10 rows and 4 columns with random values. Okay, 10 rows and 4 columns. Okay, and I can also pass like this multiple, like let's say 100 rows and 40 columns. Okay, so this will be quite big array. Okay, now let for as of now, let's keep it simpler. Okay, so yes, and yes, of course, if you want to learn more about this random library and NumPy, the best thing I would recommend is, of course, documentation. Okay, so let's have a look at NumPy documentation. Okay, and yes, everything you will find over here. Whatever you want to learn, arrays or random number or arrange, everything, right? So yes, now I'm sorry, just having a little bit trouble with cough. Okay. Yes. So getting started. Okay. And before that, I would like to go to user guide. Okay. So here, from here, you can learn how we can create array, how we can do indexing or slicing on arrays. Okay. IO operations with array, then data types, broadcasting, copy and views. Okay, so yes, everything you will find over here, and you can search that as well. Let's search random. Okay, so if I search np dot random and press enter, then you can see here I can see some of the np dot random functions. Okay, so legacy, random generation, and all stuff you will find here. Okay, so yes, this seems different topic, random stat and mt19937. Okay, but yes, numpy dot random. Okay, so basically you will find everything from the documentation. I have learned numpy from documentation, from practical approaches. Okay, and yes, everything is basically from wherever you are learning anything in programming world, everything is coming from documentation. Okay, so yes, it is a good reference. All right, so yes, this is how we can generate a random array. Okay, now let's talk about something, let's say slicing. Okay, and indexing. What is slicing and indexing in array? Okay, so basically, let's say I have this random array. Okay, random array, and you want to get a particular part of the array. Mark my words, remember my words. Okay, listen my words carefully. If you want to get a particular range of the data, or if you want to get a particular number of data between a certain range, then you can simply use slicing and indexing. Okay, so if I write here random array into bracket 0, okay, and press enter, shift enter to execute cell. So what is returning, what is this returning? So basically it's returning me first row. Okay, so 0 and into bracket sorry, random array and into bracket 0, that means this is giving me first row. Okay, and again if I write here 0, then this will return me nothing but 0.05, that is my first element. Okay, and if I write here 1, then it will return me 0.26273. Okay, why it is returning me 0.627? That means this element, it is because remember, whenever I'm writing random array or into bracket 0, so this returns me what? First row. Okay, and I am writing to get first element from this 0th row. That means what is the first element in this row? Of course it is 0.6273. So that's why it is returning me, or it is answering 0.6273. Okay, if I write here 2, so what it will return? Okay, now let's change the row number. So if I write here, let's say 1, so 1, that means it will target this row, right? So basically we know that indexing starts from 0 in many programming languages. So 1 will target this row, and from first row I am targeting which element? Second element. That means this is first, this is 0th, this is first, and this is second. It should return me 0.140. Okay, let's execute this, and yes, as you can see, this is answering me 0.140 number. Okay, so this is how we can do indexing in an array. We specifically we use indexing when we want to get a certain number. Okay, now let's have a look at slicing, that we want to get a particular range of the number. If I write here 0 colon 4 and if I execute this code, then this will return me row number 0 1 2 and 3. Okay, this 4 will not be counted. Okay, but yes, this 0 will get counted, this 4 will not be included in the output. Okay, and which is often termed as non-inclusive non-inclusive outer boundary. Non-inclusive outer boundary, that means this outer boundary will not be calculated while considering a particular range, that it will return me 0 to 3. Okay, this is the starting point or this is the ending point. Okay, 0th row, that means this row, first row, second row and third row. It will not return me this fourth row. As you can see, this is my last row of the result. Okay, so my battery is low, but not to worry about it, I will just increase my brightness as of now. Okay, right. So yes, this is a starting point and this is ending point. Okay, now again, if I write here that random array or into bracket, let's say 0 comma 0, then what this is returning me, this is returning me nothing but first element. Okay, now if I write here, let's say 1. Okay, so this is answering me what, this is answering me 0 0.6273, which is this. Okay, and if I write here, let's say 1 comma 1, so this is answering me what, 0.9149. So how is this working? Basically, look, whenever we separate two values with comma, whenever we separate two values with comma, so it will consider first value as row and second value as column. Okay, so okay, first of all let me write it 0. Okay, so I'm writing here 1, that means first row, which is first row, this is my first row. Okay, don't get confused, this is first row and this is 0th row. So this is my first row and 0th element of the first row, which is nothing but this. Okay, so it should answer me 0.3258. Okay, so that's why this is answering me 0.3258. Okay, so now if I write here 5 and if I write here 2, that means nothing but fifth row and second column, as simple as that. Fifth row, which is fifth row, so let's count it from starting. 0 1 2 3 4 and 5, so this is my fifth row. Okay, and what number of column, it is second. Okay, so second, that means 0 1 and 2, so it should answer me 0.03759. Okay, let's see if I get this number, this selected number as output. So as soon as I execute, yes, as you can see, this is answering me 0.0359. Okay, so this is how we can do indexing and slicing. Yes, we can of course write here some range. Okay, if I write here random array into bracket, let's say I want first 3 rows and first 3 columns. Okay, first 3 rows, that means I will write here something like this. Okay, so I did nothing but this will be considered as 0, but I don't really need to write 0 over here. So from starting till 3, okay, that means 0 1 and 2, I just mentioned before that 3 will not get counted. Okay, so what number of row, 0 1 and 2. Okay, which will be this 0 1 and 2. I want to get, let's say, these 2 rows only, this row and this column, sorry, not row but column. I want to get this column only, this column and this column. So I will write what, nothing but, yes, if you have guessed right, so I will write something like this, as simple as that. So this will count 0 first and second column, 0 first and second column, this will not get included. Okay, but if I want only this column and this column, this column and this column, I will of course write 2 only. So this will return me, so row will be 0 1 2. Okay, whereas column will be 0 and 1, 2 will not be counted. So I shall see the result of this. This will be, then this will be in the result and this will be in the result. Okay, now let's execute the cell, and yes, as you can see that I have got the same answer like this. Okay, this much of code, like first 3 rows and first 2 columns, as simple as that. Okay, now I hope you have got my point. Yes, we can also reverse that. For example, if I write here random array into bracket, now instead of writing 0 colon 3 or only colon 3, I can write 3 colon 3 colon. What does that mean? That it will start counting from 3 to each row. Okay, 3 to each row. That means which is third number of row, third number of row. 0, 1, 2 and 3. So yes, this will definitely get counted. Okay, because this is the starting point. Remember always that when you are doing slicing or indexing, starting point will be considered but ending point will not be considered. And since now 3 is a starting point here, then this will be considered. That means 0, 1, 2 and 3. So from here to we are printing all the rows. Okay, so from here to all rows, and let's say we want all columns as well. Okay, so I can simply write like colon only. So this colon will return me nothing but all the column sum. Okay, remember, I hope my pronunciation is good and you are getting the difference between colon and column. Okay, whenever I say colon, that means I'm talking about this column, and whenever I say column, that means I am talking about this column. Okay, so if I want to get all the columns, okay, I will simply put a colon, and if I execute this, as you can see, I am getting all the columns and and the rows after third row. Okay, like this is the starting point 7781, and as you can see 7781 is the starting one. Let's say if I want one column, that means this first column only, then I can simply write here 0. So this will give me nothing but this first column only. Okay, so 0 0.77 0.008 0.77 0.008. Okay, so I hope that after this much of practical, now this concept is very clear to you, that how we do indexing and slicing using NumPy arrays and using simply square brackets. Okay, in the next segment I will be giving you a little bit of task where you can do this hands-on practical. And yes, remember this, remember that you are not watching a Netflix and you are not watching a YouTube video or any motivation video, but you are learning programming. So hands-on experience, practical experience will help you a lot in gaining your skills, right? So yes, I must recommend and I advise you to code this by yourself, so it will be easier to understand eventually. Yes, definitely I can see that for some of you it may be hard, but yes, nothing is impossible, everything is hard to learn, especially when you are learning in the industry like data analysis and data science. But don't worry, I think and I am full confident that I have made this topic more easier than it was used to be. Okay, so yes, this was all from my side in this segment only. Okay, where we learned about how we can do slicing and indexing and how we can generate a random number of arrays. Okay, so all right, in the next segment I have a task for you. Okay, where you will be able to practice some indexing and slicing practicals. Okay, and of course we will be learning about the next advanced topics of arrays as well. Okay, yeah. All right, so in this very last segment of the video, I'm gonna tell you how we can reshape our arrays. Yes, we can convert rows into columns, columns into rows, but how? Let's have a quick look at it. Okay, let me just have an heading here. So I will simply select markdown cell and write here reshaping, reshaping and transposing. Yes, we will also look at how we can transpose our array, reshaping and transposing arrays. Okay, and yes, let's create a one-dimensional array. As of now, my array is equal to np.array, and as you know that to create a one-dimensional array we will simply pass a list in this method. So 1 2 3 4 5 6 7 8, and let me just print my array. This is my one-dimensional array. Now if you want to reshape this, if you want to change the dimensions of this array, we will be able to do that by using simply dot reshape method. Yes, it is quite easy. Let's say I write here np dot reshape. Yes, we will be using np dot reshape method, np dot reshape, and I will simply pass the dimensions, not np, I will write here my array. Okay, it is basically a variable or an array that I want to reshape. So my array dot reshape. Now I will simply pass the dimensions. Now when passing the dimensions, you have to make sure that, for example, if I write here 3 comma 3, so do you really think that our this array which contains 8 element, okay, which contains 8 elements, will be able to satisfy this condition 3 comma 3? Of course not, because if we look at 3 comma 3, so it will basically generate, it basically needs 9 elements, but since we now have only 8 elements, so this will be throwing an error. Okay, so as you can see, cannot reshape array of size 8. So, sorry. So cannot reshape array of size 8 into shape. Why? Because we have now here 8 elements in an array, and we want to convert it into 3 by 3 array. So to convert it into 3 by 3, we really need here 9 elements. Yes, we really need here 9 elements. And if now I execute, so as you can see, it has been converted successfully. But since now we are using only 8 elements, we have an array containing 8 elements, so I will not be able to write here 3 comma 3. But yes, definitely I will be able to write here 2 comma 4. Okay, so 2 comma 4 should work. Okay, I didn't execute this cell. Okay, yes, so as you can see here that it is now successfully converted. I can also write 4 comma 3, which will give me 4 rows and 2 columns. So as you can see here, it has generated 4 rows and 2 columns. Okay, so yes, while reshaping an array, you have to make sure that you match the dimensions with the number of elements. Okay, so since 4 into 2 is equal to 8, and we have 8 elements in our array, so we can successfully reshape that. Okay, yes, I can also write here, let's say 8 comma 1. Okay, that will give me 8 rows. 8 rows and 1 column. Okay, so 8 rows and 1 column. If I write here 1 comma 8, so it will give me 1 row with 8 columns. So as you can see here, 1 row with 8 columns. Okay, so this is how we can reshape our array. So I hope this was useful. Now let me write here 2 comma 4. Okay, so it will generate basically 2 rows and 4 columns. So new array, I will store this in a variable named new array, and if I print here new array, and you can see the output. Okay, now it is not a big deal for you. Now if you want to transpose this array, yes, if you want to transpose this array, meaning if you want to convert number of columns is equal to number of rows, and number of rows will be equal to number of columns. So if you want to do that, you have to do nothing but simply you can write new array dot capital T. Yes, new array dot capital T. So this will basically transform our array, right? So you can convert, let me write here comment. Okay, so transpose is used, or I will write dot capital T is used to convert rows into columns and columns into rows. Yes, okay, so this was all about transposing. There is another method by which you can transpose the array. You can simply write np dot transpose. Yes, np dot transpose, not transpose, and you will simply pass our variable, which is nothing but new array. So by writing this okay, transpose, okay, I just misspelled it. Okay, it is transpose, not transpose. Okay, so yes, by writing like this, you will be able to transpose our array. Okay, so original array is something like this, which is 2 rows and 4 columns. After transposing our array, it has become with like 4 rows and 2 columns. Okay, so I hope this was useful to you, and you now have idea about what are arrays, how we can reshape it, how to work with indexing and slicing in array, how aggregation functions work. Okay, so yes, I am hoping that you now have a better and good basic understanding about NumPy and NumPy arrays. So to check your understanding over the topics that we have learned so far in this lecture, I would like to give you some theoretical and practical tasks. Okay, so in theory you have to do nothing but yes, here it is. Okay, Oh yeah, I forgot one method which is dot flatten. Okay, now let's have a look at this first. After that, I will give you tasks. Okay, so yes, my new array. Yes, my new array looks something like this, like right, which is 2 rows and 4 columns. Okay, but if you want to flatten this, okay, meaning that if you want to convert this new array into one-dimensional array back, then you can simply use np dot flatten method. Okay, so if I write here np dot flatten and write new array, and if I run this, so it will basically give me something like this, which it should not give me. Yeah, so okay, not np dot flatten, but we will simply write a new array, which is our variable that is containing a two-dimensional array. Okay, I will simply write new array dot flatten. Then this will be able to convert our array into one-dimensional array. Okay, so this was all about reshaping and transposing our array. All right, great. So far we have learned about shaping. Okay, now in the theoretical aspects, okay, so let me write it here. So yes, I will make this cell markdown cell and theoretical task. Okay, so theory task. So in the theory task, I would like you to explore some of the methods by yourself. Okay, yes, definitely I'm going to teach you that in the next lecture, in the next video, but till then it is your responsibility and it is your duty to keep learning by yourself. Okay, so I'm just assigning you some of the tasks, like what is this concatenate method, what is this. Okay, what is this s type method, what is this zeros like and ones like method. Okay, we have already seen about ones, zeros, arrange and random methods. Okay, so yes, the methods you have to see is concatenate, uh, concatenate, then zeros like, okay, zeros like, then ones like, and then there is another that is else type. Okay, so you have to explore this method by yourself, and you have to of course perform a practical about this. Okay, so this will basically help you to how you can conduct research and how you can explore things. You will be able to learn about searching, how you can search a problem and get an answer. Okay, so this is theory task. And in the practical practical task. Okay, here it is, I have written it here somewhere. Yeah, here it is. Okay, so let me cut this and paste it here. Okay, yes, so your task is that you have to first of all print this thing. Okay, so yes, okay, you will print this. So np.random.seed. Okay, seed method does nothing, but it just helps us to uh, to generate random number consistently. Okay, consistently, that means look, since it is random, it will generate anything, right? It will generate any number, but seed method helps us to generate the same number once again, right? So it will avoid basically randomity. Okay, so if I print here, okay, so just let me print here. So if I print here arr, okay, now if I again print this, you can see the output is the same. Okay, again let me run, the output is same. Okay, now you might be asking that I am generating random number, then why still it is giving me like same numbers? It's just because we have written here np.random.set. If I remove this and now run, then you can see that numbers are getting changed. Okay, look, again array got changed, again the array got changed. But to avoid that thing, I'm just adding here np.random.seed. Okay, so this just generates the same number, same random number once again. Okay, to generate same random numbers, or I would say random array. Okay, every time. Okay, so basically you won't get disturbed about your outputs, that in the first practical I had this output, why I have this output in this practical. Okay, so that's why I have just added np.random.seed. Okay, great. Now these are some questions that you have to perform. Now remember that I can't guarantee that all questions I have solved, I have given answers of all questions in this lecture, right? Because you have to do some self learning by yourself as well. Definitely we will be solving these questions, and I will be giving you some answers in the next video itself. But it is your responsibility, again it is your duty to answer or to explore the questions and problem statements, right? Okay, so the questions are very basics, and I think I have covered most of them. Okay, so you have to just some you just have to get the sum of all elements. You have to find mean value, then calculate sum of each row and each column. Okay, extract the 3 by 3 sub array from the top left corner. Okay, so yes, basically just like this, I think these are 10 questions. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so yes, these are 12 questions that you have to solve, and this will help you to gain and to gain confidence, I would say, that how much you have actually covered. Okay, so yes, I hope you liked this video. In the next lecture we are going to cover some intermediate topics of NumPy, such as saving and loading arrays. Okay, how we can work with images, and how we can perform some mathematical operations like exponent and square root, sin theta, cos theta. Okay, is none, not none. Okay, so yes, I hope that you are really enjoying this video and series. Let's see you in the very next video.